Today we're going to go over some more solving. Today we're solving inequalities. You will need a pencil and a piece of paper. And our objectives for today, already mentioned, we're going to be able to solve inequalities in graph the solution region. And then your language objective is to be able to orally explain the solution or solutions for each inequality. So all these problems are called solving inequalities. So this partner A, B thing, I'll do that part since we don't have partners. So name one symbol we use in inequalities. So you're going to need to copy everything from the blue part down. So one symbol we use in inequalities is called the greater than symbol. So greater than, and it looks like this. Oops. So the greater than symbol looks like this. Another symbol is the less than symbol. And the less than symbol looks like this. We have two more symbols, the greater than or equal to. So greater than or equal to. So that symbol looks very similar to the red one. It's going to be the red one with an equal to sign underneath it. So greater than or equal. The last one is, so there's 1, 2, 3. The last one is the less than or equal to sign. Less than or equal to. And that's going to look very similar to the green one, except it's going to have part of an equal to sign with it. So these are the 4 inequality signs that we have. So part B, what happens when we multiply or divide both sides by a negative number? So again, copy everything from the green line down on this one. So when we multiply both sides by a negative number, we must flip the inequality sign. Okay, so if it's greater than, we're going to change it to be a less than sign. So here's a first example. So we got 3x divided by -5 is bigger than or equal to 2. So to solve this, it's basically going to be like we solve an equation. Don't let that inequality sign throw you off. You're going to solve it pretty much very similar to how we solve an equation. So if I was to solve this for x, the first thing I would want to do, so 3x divided by -5 is bigger than or equal to 2. The first thing you would want to do is multiply both sides by -5. So a couple things happen here. One is that these -5s cancel. So now I get 3x is bigger than or equal to -10. However, I divided both sides by a negative, so I need to come here and I need to change this sign to a less than or equal to sign. So I'm going to do that in a different color so you see it. So because on both sides I multiplied by a -5, I need to flip the inequality sign. The next thing we're going to do to get x by itself is divide by 3. So I get x is less than or equal to -10/3. Since we're putting this on a number line below, we're going to want a decimal. So this is as a decimal, 10/3 is -3.33. So here's 0. Actually, no, let me put 0 a little further down. So here's 0, -1, -2, -3, -4, -5. So we want to plot negative 10 over 3. This is the point negative 3.33. So maybe about here. Negative 3.33. That's that point. So at negative 3.33, we are going to put a closed circle because our inequality sign had the equal to sign. So since it had the little part of the equal to sign, we're going to fill in this circle. And then your inequality sign tells you which way your arrow should be pointing. So in this one, it should be pointing to the left. So it says x is less than or equal to negative 10/3. So shade that way. I want you to try the next one. So 2x divided by 3 is less than or equal to negative 2. So pause the video and give that one a try. Okay, next one. So I have negative 9x is less than or equal to 81. So again, we are going to, how do we get x by itself? Well, it's being multiplied by negative 9. So I'm going to need to divide both sides by negative 9. So now these negative 9s cancel, and I get x less than or equal to 81 divided by negative 9 is negative 9. But notice I divided both sides by negative 9. So I need to change the inequality sign. So I'm going to erase the one that's there, and I'm going to change it to be x is bigger than or equal to negative 9. So you're going to plot negative 9 on the number line below. So I'm going to count by threes this time. So 0 on this side I would have 3. On the other side I would have negative 3, negative 6, negative 9, negative 12, and so on. So at negative 9 I should have a closed circle because I have the equal to sign there. So a closed circle, and then this time I should be shading to the right because it says x is bigger than or equal to 9. So this time we're going to shade to the right. And if you're not sure how we got that, you could also look at the inequality and it'll tell you which way your arrow should point. Okay, so I want you to try the next one on your own. So 6x is less than or equal to negative 36. Pause the video and give that one a try. Okay, these ones are going to be similar. So x divided by negative 5 minus 2 is bigger than 8. So to solve that one, just like an equation, you need to get rid of the addition and subtraction first. So we're going to add 2 to both sides first. So this is x divided by negative 5 is bigger than 10. Next, multiply both sides by negative 5. So that this and this cancel. So I get x is bigger than negative 50, but wait, I divided both sides by a negative, so the sign should change. So let's just say x is less than 50. So on my number line, sorry, x is less than negative 50. So on my number line below, I'm going to plot negative 50, and I'll count by tens. So this is 0, this is 10, this is negative 10, negative 20, negative 30, negative 40, negative 50, and so on. So I'm going to plot negative 50. This time it's going to be an open circle because I don't have the equal to sign underneath the green inequality sign. It just says x is less than negative 50. So it's an open circle, and my arrow should go to the left because it's less than. So it's going to look like that. You try the next one, and I'll give you a hint. You're going to start by adding 3. So pause the video, give it a try. When you unpause the video, I'll have worked this one out for you. So hopefully you pause the video. Here is this one worked out. First, you add 3 to both sides. so you get negative 2x is less than negative 22. Divide both sides by negative 2. So you get x is bigger than 11. So if we plot 11 on the number line, we have an open circle because it's strictly bigger than 11, and we shade everything to the right. So these get into compound inequalities. So basically you have two inequalities in one. So with inequalities, with compound inequalities, you get the two cases, the or and the and. So with the or case, x is bigger than 2 or x is less than negative 4. So we're going to plot these each on their own number line. So I'll say x is bigger than 2. So here's a number line. Here's 0, 1, 2, 3, 4. And then I'm going to shade this one. Notice there's no equal to sign, so I should have an open circle, and x is bigger than 2, so I'm going to shade to the right. For the next one, x is less than negative 4. Again, I'm going to graph the number line, plot 0, and I want x is less than negative 4. So here's negative 1, negative 2, negative 3, negative 4, and negative 5. So at negative 4, I'm going to put an open circle, again, because it's strictly less than, and I'm going to shade to the left. So I'm going to go that way. So my solution for this one is going to be what I plot on the line below. So I'm going to plot negative 4. I'm going to put an open circle there, and I'm shading everything to the left. Then I'm going to do the same with my x is bigger than 2. So I'm going to plot 1, 2, 3. So I'm going to plot this open circle at 2, and then I'm going to shade everything to the right of 2. So your solutions are everything to the left of negative 4, not including negative 4, and everything to the right of 2, not including 2. So anything that's in between those two values will make this false. So if I plug in 0 there, 0 is not bigger than 2, and 0 is not less than negative 4. But if I were to plug in, let's say 3, well, 3 is bigger than 2, so that works. So since that's true, that's a solution. And I could also put in negative 5, which would be over here. Negative 5 is not bigger than 2, but it's less than negative 4, so that would also be a solution. So there's like infinite solutions to the left of 4, not including 4, and infinite solutions to the right of 2, not including 2. So for the next one, x is less than negative 4 and x is bigger than 2. So again, I'm going to plot each of those on their own number line. So first, x is less than negative 4. So 0, negative 1, negative 2, negative 3, negative 4. So x is less than negative 4. So open circle, and we're shading to the right. Then so this is x is less than negative 4. Then I'm going to do x is bigger than 2. So x is bigger than 2 or greater than 2. 0, 1, 2. So open circle and everything bigger than 2. So for this one, we're looking for where do these overlap. So hopefully you can sort of tell, but I'm going to plot them down here. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. If I plot 0, negative 4, and I shade to the right, and then I plot 0, negative 2, sorry, not 0, negative 2, open circle at negative 4, because it's strictly less than, and then shade to the left. And then same thing for bigger, so x is bigger than 2, open circle at 2, this time I'm shading to the right. Where do these two pieces overlap? hopefully you can see that there is no overlap between them. So your answer here would be no solution, because nothing is going to satisfy both of these inequalities. So since there's an and, it would need to satisfy x is less than -4 and x is bigger than 2. And there's no solution that does this, because if I was to choose 3, 3 is bigger than 2, but it's not less than -4. Similarly, if I choose one in this region, let's say -5, if I chose that one, I could certainly say -5 is less than -4, but it's not bigger than 2. So that one was no solution. So I want you to try these two on your own. So you try this one and this one. They're very similar to the two I just did. Pay attention. This one has an and. So since it has and, it needs to satisfy both inequalities. And then this one has or. So it satisfies one or the other. So pause the video and give those a try. For these next two, it's very similar to when we solved equations. First, you need to combine your like terms. So I'm going to combine my 5a's together. I got 5a plus 3 plus 5a is bigger than or equal to -13 minus 6a. Combine your 5a's together. So this is 10a plus 3 is bigger than or equal to -13 minus 6a. And then we're going to solve this for a. So we could subtract 3 from both sides. So this will get us 10a is bigger than or equal to -16 minus 6a. Then we'll add 6a to get it over to be with the other a's. So this is 16a is bigger than or equal to -16. Divide both sides by 16. So a is bigger than or equal to -1. So that's my solution there. Include the number line. So 0, -1, -2, 1, 2. So notice I have a is it's bigger than or equal to. So I'm going to have at -1 a closed circle since I have the equal to sign, and actually be shading everything to the right. Okay, so you try that one. Pause the video and give it a try. When you unpause it, I'll have the answer there for you. So for that one, here's the work. Subtract 3 from both sides. So you get -3a is less than or equal to -6a minus 12. Then add 6a to both sides, so you get 3a is less than or equal to -12. Divide both sides by 3. So you get a is less than or equal to -4. So close circle at -4 and shade everything to the left. And one last example. So this one is also a compound inequality, but it's written as one inequality. So to solve this, we want to get what's in the middle. We want to get it to just say x in the middle. So what we can do, so it says 10 is less than 3x minus 5, which is less than 22. Or you could say 3x minus 5 is bigger than 10, and 3x minus 5 is less than 22. So you would have two separate inequalities to solve for this one. So, and there's multiple ways to solve this. This is just one way. Break it up into two separate inequalities. So 10 is less than 3x. Oops. 10 is less than 3x minus 5. And, so these ones will always have an and. So 3x minus 5 is less than 22. So those are your two separate inequalities. You're just going to solve each of those. So to solve this one, whoops, the one on the left, I'm going to add 5 first. So I get 15 is less than 3x divide both sides by 3. So we get 5 is less than x. So that's the green piece. Then the other one, 3x minus 5 is less than 22. So I'm going to add 5 to both sides. So these 5's cancel. And I get 3x is less than 27. Divide both sides by 3. So x is less than 9. I want to take a moment and say, notice I have x is on the right side and 5 is on the left side. We can rewrite this as x on the right, or sorry, on the left, and 5 as the right, but we got to flip the sign, and this is perfectly legal. So we're just flipping the sides, and that's fine. So so now the x is on the left side and the 5 is on the right side. So if you want to do that, that's fine. You just need to make sure you flip the sign. And this makes it a little easier for us to graph. So we're going to graph the green piece. So x is bigger than 5. 0, 2, 3, 4, 5, 6. Let me use a different scale. So I'm going to count by 2s. Oops. So 2, 4, 6, 8, 10, 12. So our first x is bigger than 5, so that's the green piece. So here's 5. So here's x is bigger than 5. So then I'm going to plot the red part, x is less than 9. So here's about 9 on this number line. Open circle at 9, shade to the left of 9. Now, where does the green piece and the red piece overlap? So notice my green goes as far as 5. So since it has to satisfy both inequalities, I'm going to put an open circle at 5. So 5 is as far as I'm going to go. Notice it's open circle because it still has to satisfy that 5 is not included because I have a I do not have the equal to sign there. And I'm going to go all the way up to 9. So I'm going to stop at 9 because my red doesn't go any further than 9. It stops at 9. So, and remember, it has to satisfy both inequalities. So anything that's in between 5 and 9, not including 5 and 9, anything that's in between those two values will make both of these inequalities, x is bigger than 5 and x is less than 9, is because it satisfies both of those inequalities. So I want you to try this one. To start this one off, remember you're going to have to distribute this 2 to the parentheses first. So this would be 10 is less than 2x minus 6, which is less than 22. So you're going to set up your two inequalities, solve them, and graph them on the number line. If you need help with any of these, please reach out to me on Google Classroom, Remind, or email. I'll be more than happy to help you. I posted some practice problems for you to try before our live meet. I posted them in Google Classroom.